This is Similar Shapes, Part 1, Linear Enlargement and Reduction. A shape is congruent to another shape if it is the exact same shape and size. So this 2x5 rectangle is congruent to this 2x5 rectangle. The difference is they're turned on the side, but they're still the same shape. Now, more importantly, we need to know what similarity is. Two shapes are similar if one is an enlargement or a reduction of the other. So here we can see the sides of this rectangle are 3 and 7. Multiplying by 3 gives us sides of 9 and 21 for this bigger one, so we can see that the bigger one is an exact enlargement of the smaller one. So therefore, they're similar. Now, when we are looking for similarity, we need to check that we have corresponding angles are equal and that corresponding sides are in the same ratio. So what that means is, first of all, that the angles inside the shape are the same for both. So we've got two greens and two blues here and the same in this bigger one. And the corresponding sides in the same ratio means that we are multiplying each side by the same thing all the way around to get the bigger one. So 3 times 2, 6, 4 times 2, 8, 3 and 6 again, and then on the bottom 6 times 2 again, 12. So in this example we have each corresponding angle equal, and we have an enlargement of 2 for each pair of corresponding sides. An example of a linear enlargement scale factor. So we're told these shapes are similar. Calculate the linear enlargement scale factor and the length of h. So 5 and 12.5, they correspond, because these are the long sides of the rectangles, and h and 3 correspond, these are the small sides of the rectangles. So we need to compare the two numbers that we have, which is 12.5 and 5. So comparing them, big over small gives us an enlargement. 12.5 divided by 5 is 2.5, so 2.5 times bigger. So 3 times 2.5 gives you 7.5 for h. A reduction scale factor example. So again, we're told these shapes are similar. Calculate the linear reduction scale factor and the length of w. So corresponding sides this time is 12 and 3, and the other one is 4.4 with w. So we're going for a reduction this time, so it's small over big. So 3 over 12, that's a quarter. So that's saying that the small sides are a quarter of the bigger sides. So a quarter of 4.4, we get 1.1 for W. Now, moving on to similar triangles. If pairs of corresponding angles are equal in a triangle, then that means that the ratio of corresponding sides are equal as well, and therefore the triangles are similar. So what this is saying is, if we've got angles that are corresponding, that means everything else is going to match up as well, and we're going to get similarity. And then secondly, if we've got the ratio of pairs of corresponding sides being equal, then the corresponding angles are equal, and then therefore the triangles are similar. So what this is saying is, if we get an enlargement or reduction scale factor for each pair of sides being the same all the way around, that means that the angles are going to be the same inside the shape, and therefore the triangle is similar. So to summarise that, for triangles, we only need to check for one of the conditions of similarity. One condition comes with the other for triangles. So here we are, we have two triangles here. We've got 85, 40, and we can work this one out, and I get 55. This one, 85, 55, can work this one out to be 40. So they both contain 85, 55, and 40. Well, because they contain the same angles, we can say they're similar. Here we've got two triangles, and we've only got the length of sides. So starting with the biggest side, 6 with 4, and that's a 1.5 enlargement. And if you do the same with the other side, so the middle size side, 4.5 with 3, it's also 1.5, and then 4.2 with 2.8, and that's also 1.5. So because the ratio, or the enlargement scale factor, probably the best thing to say, because they're all the same, then we can say that triangles are similar.